Okay, sorry, forgot to start the video, so I'm just going to run through these 2 pages. The answers are on here. You can pause the video if you need to, slow down, and go through the solutions. So here are the solutions. 2x minus 9 equals 7. We solve. Time to pay your bill. And well, this one expand the left side, expand the right side, solve, and then we checked, so we did a verification. This is called a two-sided, left side, right side verification. You work out the left side separately, the right side separately. And this one, you work out the left side separately, substituting in the value that you think for x, you get a number. You work out the right side separately, substituting in everywhere you see an x, putting in the 5, get a number. These two numbers are the same. It verifies. The equations we solved were linear. The two other equations are quadratic. They'll give you x squareds. Okay, we're caught up. How can the graph below be used to solve the quadratic equation 2x squared plus 5x equals 12? So what are we looking for on this graph? So I want you to, here, you can assume this is y equals 2x squared plus 5x. Okay. So if I have 2x squared plus 5x, how do I solve 2x squared plus 5x equals 12? You don't have to solve it just yet. I just want to know how you solve it. We have an assembly to go to later, so we better. This is the line y equals 12. So the y value of every point on this line is 12. What I want to find is, what's this x value? And what's this x value, right? This has coordinates. Let's call it x1 comma 12, and this has coordinates, and let's call that x2 comma 12. Right. There's values of x that will make the left side of the equation 2x squared plus 5x equal to 12. Right? That's what we want. We want to know what is the value of x that makes this equal to 12. And you can see this is not exactly a nice number. It's somewhere between 1 and 2, and maybe this is -4. I don't know, but let's find out. So we're going to use our calculator to do this. So I'm just going to drag this across. Okay, so let's go to y equals. So we're going to need two equations, right? 2x squared plus 5x. That's y1. And y2, the other equation, is 12. I'm going to set my window so it looks like this window, okay? Which means I'm going to go to window. My x band, I'm going to go like from -6 to 4 with my x's by 1s. And with the y's from -4 to like 15. I'll make it 16. Okay, and we'll go by 2's. This way the scaling will match, right? The scale is 2, the scale is 1. Okay, and we're going to hit graph. And so we should be looking at a very similar graph, right? Because we set the window pretty much the same. And it looks pretty similar, right? You can see it is going through 0, 0 there, this graph. So second calc, we've done this for a while now, intersect. So I'm just going to move to about the point of intersection and hit enter 3 times. 1, 2, 3. We get 1.5. Okay, so this x value, 1.5. x1 is equal to 1.5. What was that? And let's go to y equals. Oh, no, sorry. Let's go just to the graph. Second calc intersect. Now, I'm on y1, so if I move it, it's going to go all the way down and back up. So what I'm going to do is shift the graph to y2 using the arrow. See, now it's y2 equals 12 here. So when I move left, I'm just going to be moving along the straight line. Right? which is going to take a lot less time than having to go all the way down and back up again. And it doesn't matter, I only have two curves, it doesn't matter which one's first. I go close, hit enter 3 times, the intersection x equals -4. So x2 equals -4. And that's what it looked like on here, right? But to know for sure, we either solve it graphically or we could do it algebraically and put a -4 in to the left side and see if the left-hand side works out to 12 if I put -4. Okay, any questions on that one? So we have two different curves, right? We have 2x squared plus 5x, that's a quadratic. We've got y equals 12, that's linear, it's a straight line. Right? It's actually a horizontal line, it's not even on an angle, it's not oblique. We put them into the calculator, y1, 2x squared plus 5x, y2 was equal to 12, so I put like a y1, y2, and then we found the intersection of the two curves, and we're interested in the x value. Miss something? How can the graph below be used to solve the quadratic equation 2 times x minus 3 times x plus 4 equals 0? So just assume this is y equals 2, x minus 3, x plus 4. How do we find where it's equal to 0? So what value do we want to be 0, x or y? Want the y value to be 0. Where is the y value 0? Right here, right, along the x-axis. So when is y equal to 0? -4 and +3, right? So x equals -4. So in this case, what we're doing is looking for, we call it the zeros of the function, right? So you could graph this, 2 bracket x minus 3x plus 4. But I'm just using this graph, right? Here it was a little bit harder, so I used the calculator to help me. Didn't know if that was exactly 1.5, it was. Okay, but if we can, we could read the values off the graph, right? So we could have read this as being 1.5, read this as being -4. Okay, any questions on this one? This page, or part of the page. Let's look at solving another quadratic equation graphically using the concepts from above. Okay, so we had a couple of examples. First method, graph two functions and find the point of intersection, right? That's just like the graph that was on the left side, right? We had two functions, 2x squared plus 5x, we had 12, we were finding the points of intersection, and more importantly, it's the value of x where they intersect. To solve the equation, x squared minus 4x plus 1 equals x plus 1, we need to determine all the values of x that would make the statement true. In other words, all values of x that make the left side of the equation equal to the right side. Just like our verification, right? Left side, right side, want to see if they're equal. The x values can be found graphically by first graphing y equals the blank side of the equation and also graphing y equals the different blank. So which side? The left side and then the right side. Okay, let's do it. Graphs of y equals, so they're shown below. Label each graph. So which graph is this one? This or this?
First one.
First one, right? Yeah, it's obviously the quadratic. Okay, so this is y equals x squared minus 4x plus 1, and this is y equals x plus 1. That's gone all fadey. Okay, so what are we looking for? Even though this is gone. It's back and it's gone. Try that again. Circle the points on the graph where the two functions are equal to one another. So where am I circling? So here and here, right? So that's where they're equal to each other, right? They have the same x value, and it gives the exact same y value. Okay, so if we substitute that x value in to either equation, we're going to get the same number for y. So they're equal to each other. State the x values that will satisfy the equation. So what are the two x values where these graphs are equal to each other? 0 and 5. Okay, so 0 and 5. So x equals 0 and x equals 5. Algebraically verify both of the answers by substituting them back into the equation. Okay, so we do the same thing, right? We're going to do a left side is x squared minus 4x plus 1. Right side is equal to x plus 1. We're going to go in, we're going to throw in an x value of 0 and work out the left side. So this is equal to 0 squared minus 4 times 0 plus 1. And this is equal to 0 plus 1. And so they're both equal, right? That's actually pretty easy because, putting a 0 into the left side just left us, in the right side, either way. We're just left with the constant value. To verify the 5, we need to do the same thing, only instead of x, I'm going to put 5. So I did the right side first because it's easy, right? 5 plus 1. Okay, that's 6. On the left side, yeah, 25 minus 20 plus 1, which is 5 plus 1, or 6. So they both worked out to 6. As should be expected, right? If we look at the graph, it's at the point 5, 6, right? This is at the point 0, 1, right? When x is 0, y is 1. But this is an algebraic verification, right? So that we know for sure this is right. Sometimes you read a graph, maybe it looks really close to 5, but it isn't quite. Might be a little bit over 5. It's hard to tell. It's 5.01 or something. It's next to impossible to tell. When you verify algebraically, you'll know if it's true or not. True. Okay. Questions? No? Just graph the two graphs. Find the intersection. You can use your calculator. You can read them off the graph. First method. Graph y equals the left side of the equation and y equals left side, right side of the equation. The blank coordinates of the points of blank will be the solutions. So what are we looking for the solution? The x coordinates of the point or points of. Two things come meet. Intersection. Just like on the street. Okay, two roads cross, there's an intersection. Two lines cross, there's an intersection. Magic. It's the magic erasing board. Yeah. Well, it's just make me fill it in again. So left side, right side. The x coordinates of the points of intersection. Okay, very important. We don't care about the y value because the y value is the same. We care about the x value. What x value? Second method. Rewrite the equation so that one side is 0 and find the x-intercepts. To solve the same equation, x squared minus 4x plus 1 equals x plus 1, using a different method, we still need to determine all the values of x that make the statement true. However, when using this method, we rearrange the equation such that one side is equal to 0. The equation rearranged will now be. Okay, so we need to rearrange this, right? Now, one of the advantages of doing this is, like on the first example we did, where it was 2x squared plus 5x equals 12, normal graphing window isn't even going to show the 12. So you got to start playing with your graphing window to move it around, right? Whereas on this one, we're looking for the x-intercepts, right? The values where y is 0. That always shows us right in the middle of the window. So that's easier to see. You usually won't have to adjust to see that. Okay, so what we do is this. We got x squared minus 4x plus 1 equals x plus 1. So I'm going to subtract x from both sides. Okay, so the x squared stays. I'll get minus 5x. I'm going to subtract 1 from both sides. Well, that's just 0. So we get x squared minus 5x is equal to 0. So the equation rearranged will now be y equals x squared minus 5x. Okay, so rearranging, right? You just got to do the opposite, right? This is an x being, I want to get rid of this x. I'm going to subtract x from both sides. I'm going to subtract 1 from both sides. Okay, good? The graph of y equals x squared minus 5x is shown to the right. Okay, so this is, again, this is y equals x squared minus 5x. Now, what are we looking for? We labeled the graph. Since we're trying to find the solution where x squared minus 5x equals 0, we need to look where the graph of y equals x squared minus 5x has a y value that's equal to 0. Circle the points on the graph above where this occurs. So we're looking for the zeros. So we call them the zeros of the function, right? They're the values of x that will make, or sorry, the zeros of the equation. It's the roots of the equation. Yeah, equation has roots. The graph has zeros because it's the values where the graph is equal to 0, or where the y value is equal to 0. And the factors of the, also the factors. Circle the points. So we've got the points where that occurs. We want the x values. Okay, so 0 and 5. Substitute them back into the equation. So the left side is x squared minus 5x. The right side is equal to 0. Okay, so we don't have to evaluate the right hand side this time, right? And we've got two values we want to do this for. And that checks as well. Okay, so we have solved it. We have algebraically verified the solution. So you might get some questions that say algebraically verify, right? And then you have to do that. You have to substitute it in and show. If not, you can still verify it algebraically by just plugging it into your calculator, right? Just saying, well, I'm just going to go 0 squared minus 5 times 0, and I'm going to go 5 squared minus 5 times 5, and I expect to see a 0. And for the other one, if you were going to verify it on your calculator, then you would just go in and you'd work it out on two separate lines, right? You do the one expression, you do the x squared minus 4x plus 1. And it's going. You do the x squared minus 4x plus 1 on one line of your calculator, right? Go 0 squared minus 4 times 0 plus 1, enter, and you'd go 0 plus 1, enter, and then do the same thing, right? So even if you're not asked to algebraically verify, you can still do that on your calculator and verify. Okay, next. Second method, rewrite the equation. So one side of the equation is equal to 0. Graph the left side, right? Because we're going to make the left side that has something, the right side of the equation. Graph the left, I don't know, left hand maybe? Graph the left-hand side of the equation, the of the graph are the solution to the equation. So what are we looking for? The x-intercepts, right? The x-intercepts. Which is where an x-intercept occurs when y is equal to 0. Remember, both methods will give the same solutions since both methods solve the same equation. Okay, so it may be your choice and maybe our choice. We may say solve by graphing, graph the left side is y1, right side is y2, do an intersection, and we might say solve the equation, set the equation equal to 0 and then solve. Example 2, what is the maximum number of solutions? So if you think about it, if you've got that quadratic and you got a straight line, what's the largest number of solutions you can have? 2, right? Could you have 1? Yeah, you could have 1, and you could have how many? 0. So we've got a few situations, right? We could have a quadratic like this, and here's the line down here, right? So you got no solution, right? They won't cross. You could have quadratic and the line, and it's just touching at one point. That would be one solution. Or you could have what we've already seen, right, which is quadratic, and there's the line, and it has 2. But we can't have more than 2. So most 2 and at least 0. Solve 2x squared minus 4x minus 1 equals negative 2x plus 3 graphically using both methods and your graphing calculator. Okay, so method 1. Turn calculator on, go to y equals. Let's clear out whatever's in there. Clear. So method 1, what do I put in for y1? Two x squared minus 4x minus 1. And what do I put in for y2? Okay, so negative 2x, right? You're using this little negative down here, negative 2x plus 3. And I'm going to go zoom standard, right? Just to go back to a standard window, and if I want to, I'll adjust afterwards. Okay, but I can see everything in there. I could kind of zoom in on it, but I don't need to. Right? I can see that my 2 solutions are inside the window. And what are we looking for? We're going to do the intersection. So calc. Number 5 is intersect. And I want to move, to about there. Hit enter 3 times. I get negative 1. Okay, so let's see if we're going to graph this. Graph looks like. Okay, so we got negative 1 and 5. Negative 1 comma 5. So we got x equals negative 1. Right, that's what we're interested in. And second, calc intersect. And pop back around to the other. Whoops. Get close. Enter 3 times. And we've got 2 and negative 1, right? 2 comma negative 1. So x equals negative 1, x equals 2. Okay. Those are the 2 values of x that make this true. Okay, now method 2, right? So what do we graph? y1 was the left side, y2 was the right side. We look for the intersection. In the next method, we rewrite. So we get 2x squared minus 4x minus 1 is negative 2x plus 3. So what are we going to do with that negative 2x? How do we get rid of negative 2x? Add it to both sides, right? So we're going to add 2x to both sides. So this will be 2x squared. Okay, if I add 2x to negative 4x, what do I get? That might be the mark on the question, but so negative 4x plus 2x is negative 2x, right? Okay, what do I do with the 3? I do what to both sides? subtract 3. So what do I end up with? Minus 4. What's that equal to? 0. Okay, it's equal to 0. We go back to our graphing calculator. Drag it over here, so we go to y equals, we'll clear out what's in there. Okay, we'll enter 2x squared minus 2x minus 4, 2x squared minus 2x minus 4. And we'll hit graph. Okay, I'm leaving the window the same. Solution should be the same, right? It should be, I don't know, they're hidden under the calculator there, but what are they? We got like -1 and 2. Our solutions, yeah, -1 and 2. So x equals -1. Now on your calculator, if you're not sure, you could do a couple of things, right? So one thing, I could go into the table, second table, right? I could say, okay, when x is 2, I've got a 0, right? What about when x is -1, I've got 0, right? So square brackets in the table, and it says you get a value of 0. And these are all exact values, so I know that's true. If I'm not sure, I can graph and do second calc. Number 2 is 0. So that wants a left bound. I go to the left of 0. I go down here, and I take a guess. -1. Same thing would happen on the other side. Another option, you go to y2 and set that equal to 0 and graph. Now you won't see this line unless you got one of the 84 colors. They're kind of fancy. They'll draw a nice line on there. And we can do an intersect again this time, but this time we're intersecting the line y1 with y2, which is 0. We're intersecting with the x-axis. We just gave it that equation. We also get -1. Okay? I prefer the intersect to the 0. It's just kind of faster. You just move to the point, hit enter 3 times. You don't have to go to the left and then over to the right and then take a guess. Okay, we could also verify these algebraically. You could do method 1 algebraically, you could do method 2 algebraically. I'm not going to unless it asks me on the next page, which it doesn't. So, take a look at the next example. A practical example. The surface area of a cylinder can be determined using surface area is 2 pi r squared plus 2 pi r h, where r is the radius of the base and h is the height of the cylinder. Right? So think back 10, measurement. Here's the formula. Suppose the height of a particular cylinder is 12 centimeters. Write a formula for the surface area in terms of the radius. Okay. Suppose the height is 12 centimeters. Write a formula for the surface area in terms of the radius. So what do we want to do? We're going to put a 12 in for h, right? Wherever you see h, you put in a 12. Okay, so we'll start off with surface area formula. Surface area is 2 pi r squared plus 2 pi r h. So that's my formula. It either came off the formula sheet or was given to me. In this case, it was given in the question. We're going to substitute in surface area is 2 pi r squared plus 2 pi r times 12, right? Because they told us the height was 12, and they just want us to get an equation for the surface area of this 12 centimeter tall cylinder. So it'll be 2 pi r squared plus 24 pi r. So pi, we know is just a constant, right? And we've got the pi key on our calculator. So r is the variable. It's the only thing that varies. So now we're asked in B, what's the radius if the surface area is 175 square centimeters? State your answer to the nearest hundredth of a centimeter. Okay. So we know the surface, so we're going to take this same formula, right? We're going to put in 175 for the surface area and write it out. 175 is equal to 2 pi r squared plus 24 pi r. That's a quadratic, right? We got an r squared, we got an r. 2 pi is just a constant, right? 2 pi is like 6.28, whatever. 24 pi, yeah, it's just a number, right? 24 times pi is 72 point something. Right? It's just a number. Okay, two choices. We can do left side 175 for y1 and 2 pi r squared plus 24 pi r for y2, or we can rearrange it and set it equal to 0 and then find the x-intercepts. Which do you prefer? Method 1 or method 2? So think about it. If we do method 1, we're going to have to expand our window so we can see 175. If we do method 2, we should just be able to see it along the axis, right? We might have to, depending on what it looks like, we might have to expand our window out, but we won't have to take this up to 175, right? So maybe let's try this. We'll go 2 pi r squared plus 24 pi r minus 175 is equal to 0. Okay, so method 2, rearrange. Get the right side equal to 0. Okay, let's pull the calc up and over. What do y equals? I'm going to leave y2 as 0, right? Because I still want a 0 there. I'm going to clear this out. So it's 2 second function pi x squared. Okay, we can't use r, we're going to use x, right? Plus 24 pi x, right? Now your calculator is going to multiply. If it sees 24 and then pi next to it, it knows to multiply. Minus 175, and y2 is 0, right? So looking for intercepts. And let's graph that and see what we see, if anything. Okay, so there's part of the graph. Now I don't know if the rest of the graph kind of goes over there. So we can go into the table just to get an idea, right? We're not interested in negatives, right? Because we're interested in a radius. So, what I want is, I want to know the value when this is 0, right? And it looks like, well, it's going to be in here somewhere, like it's pretty close to 2. Right? Pretty close to 2, because that's 0.929, and there's negative 93. And 0 will be somewhere in between that. And otherwise, the numbers just get bigger. Okay, so if we keep looking down here, we see like numbers just get bigger, 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 bigger. So I don't need to go that far out. Okay, so we're looking somewhere between 1 and 2. So go back to the graph, say, well, that's this guy. So second calc intercept. First curve, I'm going to move this down. So my first curve is y2 equals 0, and I just move over. Okay. It's easier to move along the line y equals 0, right? Then hit enter 3 times. Second curve will be function, and there we go. 1.9907. Its nearest hundredth of a centimeter will be 1.99 centimeters. Okay. So r is equal to 1.99 centimeters. So if that had been 1.995, then it would be 2.00, right, after rounded. But it was like 1.990 something. So the radius 1.99 centimeters. Okay. So how do I know? Let's go back up here. Let's go to my calculator. So that's the x value, right? So if I go quit and just type in x, see if I just type in x, it's going to give me that number, right? Because it's stored in x, right? So now I can go back and I can go 2 pi x squared plus 2 pi x 12. Let's throw in a multiply there, times 12. And what should I get? 175, right? 175, okay? That's the way to check, right? Hey, is that the right value of x? I think it is. We did everything right. We did all the steps correctly. Can I verify it? Yeah. Where is the x value? It's in my calculator as x, right? So I just use x. There we go. Is that it? Done.